Hi guys, today we'll be looking on some of the different uh, organic compounds, the list which was not covered into the previous classification. These are some of the rare compounds to exist in nature, but obviously we have to study them for the scope of our preparation. Okay, so these compounds are called bicyclo compounds. And the examples can be this one or this one. So, by the definition of the bicyclic compounds, if two or more carbon are common in two rings, then it is called as bicyclic compound. Okay, but the catch here is if in the ring only one carbon atom is common between the two rings, then it's called a spiral compound, and if exactly two carbon atoms are common between the two rings, then only it's called a bicyclo compound. So on the other hand, we can have something like a spiral compound as well. Spiral compound, in which we can have something like this structure, in which only one carbon atom is actually common in between the two rings. Here, as you can see, that there are two carbon atoms which are common between this ring and this ring. Similarly, there are two carbon atoms common between let me draw the ring structure as well. This ring and this ring and this ring. Yeah, so this is the second ring and this is the first ring. So two carbon atoms, these two carbon atoms are common between the two rings, right? In this bicyclo compound as well, these two carbon atoms are common between this ring and this ring. Okay, so let's now go into what is called as double bond equivalent, or degree of unsaturation or index of hydrogen deficiency. So we'll be calculating all these values. All those are the same name of all these are the same value, and just that the names are different. So we'll be looking into calculation of this double bond equivalent value of organic compound. This is one of the questions which is asked in every year JEE paper, and this is the most important thing which is asked from the students every year. So let's look into that. Okay, so we have something called degree of unsaturation, which is also called double bond equivalent. Which is also called index of hydrogen deficiency. So why I'm giving you all these different names for the same value? Because the paper setting authorities can actually come up with a question of find the number of unsaturation or the degree of unsaturation in this following compound, or they might come up with asking you what is the double bond equivalent of this organic compound, or they may ask you what is the index of hydrogen deficiency in this compound. So you should be aware that all these different names actually point to the same value. So you may not get surprised at that point of time that okay, you don't know this thing. You actually know this thing, but it just that it has different names. So this kind of thing actually happened in some of the previous year question papers. So just from the experience of that, I'm just telling that. So what is the formula of calculating this value of DBE, which is this name is actually popularly used by people, so I'll just use this name only to refer uh, all these nomenclature in the future lectures as well. Okay, so the formula is for calculating DBE of organic compound is C plus 1 minus H plus X minus N by 2, where C is number of carbon atoms, H is number of hydrogen atoms, X is number of halogen atoms. I hope you remember what is called a halogen. A halogen is nothing but fluorine, bromine, chlorine, iodine atoms attached to a carbon in a organic compound. Okay, nitrogen is number of, so okay, N is number of nitrogen atoms in an organic compound. So this formula gives us a way through to calculate the DBE of organic compound. Just remember this formula, so you may not need to remember it after you get some practice on the calculation of DBE. Okay, so as said, in the next lecture we'll be continuing on to calculate DBE of some of the organic compounds, so as to give you some hands-on practice and experience on calculation of DBE, so that by the end of that lecture you would get a strong feel of the calculation of DBE of certain organic compounds, right? Okay, bye.